Hello everyone. In this video we're going to be solving a calculus problem. Y equals mx plus 1 is tangent to y equals k times the square root of x at x0 comma y0, and we're going to be finding the x0 value here. Okay, of course certain conditions need to be met here. We need first of all that m does not equal 0, and then k squared and 2m can be compared, so on and so forth. So under certain conditions, which are going to be kind of obvious towards the end, we want to find the x0 value for which these functions are tangent. So we're going to be using some calculus concepts here, so let's go ahead and talk about them. First of all, if a curve is tangent to a line or vice versa, that means that they are intersecting at a single point, right? So we can replace x with x0 and y with y0. So let's go ahead and do that first. If I do that for both of these equations, since this is kind of like a system, I get y0 is equal to m times x0 plus 1, and y0 equals k times the square root of x0. Of course, the x0 value needs to be positive here in order for that to be defined, so on and so forth. Like I said earlier, under certain conditions, this is going to work. Now, from here, we can set the y0 values equal to each other and kind of find an equation for, x0, and which is what we're trying to find. But m and k are kind of like parameters here. They're variables. We don't know their values. And obviously, we're going to be finding the x0 value in terms of m and k. So let's go ahead and leave it at this for now. And let's go ahead and look at this from another perspective. So we don't have enough information to solve this problem. But of course, we're given something like this now, right? We do have a line whose y-intercept is 1, and then we do have a square root function. So a radical function is going to have a domain of non-negative numbers, so it's going to look pretty much like this, something like that. And then the other function is going to be tangent to it, right? And it is going to be a straight line that passes through 1, so it's going to look like this. And the y-intercept is going to be 1 for this line. And we're saying that, or we're told that the line is tangent to the curve at x0, comma y0. All right, great. Now, and you can also see that y0 needs to be greater than 1 as well. So, how do we go about this? Well, since the line is tangent, this means that if I find the tangent line to the curve by using calculus, then I can find the slope, right? So what is the slope defined as? So m tangent, the slope of a tangent to a curve at a point, is defined as the derivative at that point. Great. So what I'm going to do then is I'm going to differentiate this function with respect to x, of course, and then replace x with x0. That's going to give me the slope of the tangent at that point, which is the slope of the line, which is m, by the way. So our m tangent here is going to be m. So let's go ahead and differentiate the second function. How do you differentiate k root x? Well, k is a constant, so it's just going to stay. The derivative of the square root of x, as you must know if you're doing calculus, is 1 over 2 root x. But if you didn't know that, you could actually come up with that rule real quick. You can just write this as x to the power 1/2 and then use the power rule. Of course, you have to know the power rule. If you don't know the power rule, then you need to learn that first. So the derivative of y is going to be k over 2 times the square root of x. But I want to evaluate this derivative at x0. So let's go ahead and replace x with x0. And that's going to look like k over 2 times the square root of x0. So this is the slope of the tangent line, which is the first derivative at x0. And of course, it is equal to m, because we said that the derivative of the function at a point gives us the slope of the tangent, which is basically the heart of calculus. Great. Now, we did get another equation. So we have this, and we have this. So how do you put those together? Let's go ahead and work those equations together, and then we'll find the x0 value in terms of k and m. Okay. Now, how can we associate these two equations? Well, first of all, notice from the second equation, I can isolate the square root of x0, which is kind of important because notice that I do have a radical here, and I don't really want to deal with quadratic equations. So let's keep it simple. Let's go ahead and isolate x0, the square root of that, we can write it as k over 2m. And notice that in the second equation, by setting these equal to each other, of course, let's go ahead and set those equal to each other. K times the square root of x0 equals m times x0 plus 1. This means that at the point of tangency, the curves, the functions are touching each other, so they have a common intersection point. Now, what I can do here is basically replace this radical with this one, and that'll do the trick. Let's go ahead and do that right now. So replacing the radical x0, I can write this as k times k over 2m equals m times x0 plus 1. Of course, I want to multiply and simplify this a little bit. And let me just go ahead and write down mx0 plus 1 on the left-hand side and write this as k squared over 2m. Of course, my next step is going to be subtracting 1. And then that should look like this. Making a common denominator, it's going to look like this. And finally, dividing by m, my x0 value is going to be k squared minus 2m divided by 2m squared. Of course, here, the x0 value, and you can tell that obviously the x0 value is not going to be 0 because there's no way these lines can be tangent at 0, right? Well, can they? Well, kind of think about it, see what happens if that's the case. You can kind of play around with this because these are variables. By the way, you can put these functions on Desmos and use the sliders for k and m values, and you can kind of play with this. Like, it's kind of fun to do. And if I don't forget, I'll just share a link with you as well. Anyways, so this is the x0 value in terms of k and m, and we found it. Now, I know we didn't ask for it, but as a bonus, maybe we can talk about the y0 value as well, right? What is the y0 value? Well, the y0 value can easily be found because we do have these functions here, right? So the y0 value would be k times the square root of the x0 value, or m times the x0 value plus 1. So if you use the first one, let's just say we use the first one, y0 can be written as, m times x0 plus 1. What you can do is you can just go ahead and multiply x0 by, m, which is going to give you k squared m minus 2m squared divided by 2m squared. And then you can just add 1 to it and then make a common denominator. And you're going to be getting, something like k squared m minus 2m squared plus 2m squared, which is going to cancel out, obviously. So we're going to get something like this. Let me do it here. Minus 2m squared plus 2m squared over 2m squared. These two are going to cancel out. The m is going to cancel out if it's not 0. And you're going to end up with k squared over 2m. Okay? So y0 is going to be k squared over 2m. All right? That's going to be it pretty much. And this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed the video. Let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.